All right, guys, in an effort to try to continue helping you understand what we're doing with rationalizing and simplifying rational functions, I've got another example, and you can press pause and play as much as you like on this one, and hopefully it will help you out. So the problem behind me is the one we're going to do. We're going to divide this rational expression by this one. Now, as we do this, as we kind of talked about again today in class, you pretty much have to factor everything. Every component, top, bottom, of both of these rational expressions, you're going to factor completely. And here is how we do that. We do that according to finding a GCF first. Always check that first, and then try to use the Steggy method, the little shortcut of factoring any polynomial. Then the next thing we're going to do is we've got a special thing here because this is division. When you divide by a fraction, you multiply the reciprocal. You flip 3x over x plus 2 to x plus 2 over 3x. And then the last thing is we look to cancel. So I'm going to do that here, looking for GCFs as I go. I'm going to go top left, top right, bottom right. But I'm also going to flip these over. Actually, I'm going to go ahead and do that now because there's nothing actually to factor. I can't factor these any further, so I'm going to end up multiplying by x plus 2 over 3x. So I come back to my original, the leftmost, and I see there is a GCF that will come out. 3x is common to both terms. That would leave me with 2x minus 1 on the top. The second part, that's a difference of two squares, x squared minus 4. So recognize that. If you don't, you can still find that by doing the Steggy method. But remember, these factor a special way. X plus 2 times x minus 2 is how that will factor. Take the square root of each section. Now what we're going to do, since we have factored everything, we found GCFs, we've done the Steggy method where we can, we've done our division rule and rewritten things, now we're going to try to cancel things. You have to try to get the entire groups of things, an entire set of parentheses. So as I'm looking through this, I see that x plus 2 cancels out with x plus 2, top and bottom. The other thing I see is that there are 2 3x's. Each one of those will also cancel out. And what I'm left with is 2x minus 1 over x minus 2. And we can't go any further because these terms are separated by addition and subtraction. We've talked about that before, so make sure you're not going to try to cancel 2's or cancel some sort of x here. This would actually be our final answer.